Hey everybody, welcome to Gradeful's daily test prep chat. I'm your host, Patrick Spano, and I'm with Mr. Alex Torres. We are both test prep experts and tutors. We've been doing this for many years. Gradeful, if you're not aware, is a test prep company. It's a newfound company with years of experience. It's a rebranded company with a lot more experience, a lot more expertise, and we offer help for the SAT, the ACT, and the PSAT. And we have these daily chats at noon Eastern time where we just discuss everything dealing with test prep, answer explanations, formulas to know, SAT, ACT. We haven't gotten into the PSAT yet. So please comment if there's anything you'd like us to go over. We're always looking for different ideas and topics. For today, we'll be going over ACT math formulas you need to know. It's a continuation from our episode of yesterday. We got through a decent amount of them. We'll be going again today through stuff you should know. So if you're preparing for the February test, it'd be good to check this out. If you're preparing for the SAT, also good to check it out. And if you're bored and you have nothing else to do, we're pretty cool guys. So it's also good to check out. And yeah, make sure to comment, like, and subscribe. We have a lot of content. You can look on our channel. And yeah, so I'll let you take it from there, Alex.
Alrighty, so like Patrick said, welcome. We have an ACT math playlist on our YouTube page. And so if you want to see some of the other memorization tips for the ACT, you can go ahead and take a look there. So for now, we'll go ahead and get started with the next one on our list, which is area of a rhombus and area of a kite. So, first of all, what is a rhombus and a kite? A rhombus is going to be a quadrilateral with all four sides congruent. It usually looks kind of like a parallelogram, something like that, but all four sides are equal. And then what is a kite? It looks like a kite, right? I actually do a lot of kite flying with my kids as well. And a kite is going to be symmetrical left to right, but not symmetrical up and down. And both the rhombus and the kite have a 90-degree angle at the place where their diagonals intersect. So that's very important to be aware of. But the area formulas for both are D1, D2 over 2. So diagonal 1, diagonal 2 over 2. And so there are just like a variety of ways that those questions can be asked. So for instance, just to give you sort of one, let's say, possible way that you might see something like this on an ACT, you may get this being 5, this being 13, and let's say this piece right here is 11. So that's a kite. We know because usually we'll be just told this is a kite, and we'll be asked to find the area. And so it'll be kind of a combination of Pythagorean. Usually what you won't get would be this right angle right here. So you have to know, okay, it's a kite. That means the diagonals are congruent. So let's go ahead and put that right angle symbol back. Now we can use Pythagorean, which I won't do right now in the interest of time. But you should know that the 3, 4, 5 special triangle is for right triangles, not special triangle, but 3, 4, 5 right triangle is an important one. And also 5, 12, 13 is another important one. So if we had done Pythagorean here, making sure that 13 is the C of the Pythagorean, you'd get 12. Now, like I said about a kite, it's symmetrical left to right. So this will also be 12. And now we can use the formula D1, D2 over 2. We're talking about the diagonals. So one diagonal is 12 plus 12, 24. The other one is 5 plus 11, 16. And we're dividing it by 2. Whatever that calculates to would be the area of this kite. Same area for a rhombus. And like I said, the rhombus also has the diagonals perpendicular. So that's it for that one.
And let's see. 192 if you want to just fill it in case anybody is holding us.
Very good. Very good. Appreciate that. Yeah, you
hoping my calculator is
my laziness
be correct
seem like,
time.
You know what? Figure it out on your own, ladies and gentlemen.
Very good. All right, so that's for the kites. Are we going to go over an example for the rhombus or move on to the next topic?
We'll go ahead and go straight to the next one.
All right, perfect.
All righty. So the next one on my list would be the area of a trapezoid. So for a trapezoid, the area formula is 1/2 B1 plus B2 times H. So you've got a trapezoid. A trapezoid means that one of the sides are parallel. So top and bottom are parallel. But let's say for this particular trapezoid here, Once again, you know, you're rarely going to ever get a situation where they just give you everything and you plug it in. There's always a little figuring. So let's just imagine this is 12 and this is 13 and this piece right here is 10. And let's say the top base is 8. So, you know, a little bit of calculation that would often need to be done in a question like this before we solve. So once again, we would use Pythagorean to find out that this is actually a 5, 12, 13 right triangle on the side. And now we have everything to plug into the formula. So now that I know I've got a calculator guy, this is so liberating for me. I can live freely. 15 plus 8 for the top base and bottom base, because you have 5 and 10 for the bottom. And the height would be 12. And calculator guy, what do we have for that?
That's what I'm being subjected to now as calculator guy.
Hey, man.
My calculations are correct. It should be 138.
Surprisingly valuable role you're playing right now, let me tell you. So, yep. So that's area of a trapezoid. Just all of these are just bricks in the house, just things that we need to know. And if you don't know them, how are you expected to get the right answer on an ACT? Like I said in an earlier podcast, we're sticking to the formulas that we're expecting the ACT to not give you. If it's anything with any further complexity than the level of what we're talking about, chances are in parentheses in the problem, they'll just go ahead and tell that to you.
Very good. So next one, also just actually a point on that. So for anyone who's watching or watched our past video, these are formulas that, in case you're wondering what you should be studying, what you should be doing, practice tests, before you take your test, you should have these memorized. Correct, Alex? You'd agree with that?
Exactly. There's no proceeding forward. Do not pass go. Do not collect $200. That's a Monopoly reference. If you don't know these critical formulas here. So the next one on our list would be the 30, 60, 90 triangle. Another must know, and a variety of questions we can ask on that. And you know, a lot of these subtopics we'll do further lessons on in the very near future. But the ratio for the 30, 60, 90 is x 2x x root 3. For the 45, 45, 90, x root 2. And, you know, so the thing about special triangles is that you'll only be given one side. So if you're given one side of a right triangle, you know, maybe you can wonder if that's what's going on here. In terms of remembering, the one on the right is a little easier to remember. The one on the left is a little tougher. Maybe the memory tip here is that, you know, we're going to know that the hypotenuse is the large one, 2x, right? But if you can remember that 60 is across from x root 3, you'll have a major leg up on remembering this. So one question type would be one where we find out that one of the sides is 10. So now if that one side is 10 and there's an x ratio, then we may double it up and get 20 and go ahead and multiply by root 3 and get 10 root 3 here. Another thing to look out for is they'll often use the letter x in a problem like this because they want to kind of confuse the ratio letter that you're also using. If you know it's x2x and x radical 3, and the one that you normally label as x radical 3 happens to be labeled as x in the problem, then there's a nice easy way around that. You can just simply label them b 2b and b root 3, problem solved. And another major question type that you might get from this would be, we are given the 3 angles of a triangle, or actually the 3 sides of a triangle, apologies, in any kind of way, and we find out that they are in a certain ratio. So for instance, 200c, 100c, and 100c root 3. So here, I'm being told that my sides are in a ratio of x to 2x to x root 3. And so therefore, I am responsible in this situation for knowing that this angle would be the 30 and this angle would be 60, whether that's in degrees or radians. Just so many ways that they can present this. And one more quick way, you can tell this is a more important topic than the rest. I'm almost sensing it from the way I'm talking without realizing it. But one question would be, what's the area of a square with a diagonal of 5, let's say? So what's the area of a square that has a diagonal length of 5? Well, if we draw that out, a very important sort of iteration of the special triangle rules is to say it in this sense. Any isosceles right triangle is a 45, 45, 90 triangle. So any isosceles right triangle, and these are isosceles because it's a square, so these sides are congruent, and it's a right triangle because the square provides the right angle. So now we know the sides are in the ratio of x, x, x root 2. And if the diagonal is 5, then that's 5. So using this, and we will not refer to calculator guy here and actually solve this in the interest of time. But from here, we have enough information to go ahead and say, well, if x root 2 is 5, we're able to solve for x. Once we have an answer for x, the area of a square is side squared, which is basically just length times width, but the sides are the same. So you can multiply whenever you get x, you do x times x, and that would give you the area of the square, and we'd be done. So just totally, lots of different ways that you can use special right triangles, maybe one of the top 5 things you'd want to be good at before heading into an ACT math section.
Very good point. And then I would also just like to add, I think that sometimes if you ever get an area question or shapes that aren't very common, not a rectangle, not a square, not a parallelogram, not a triangle, not a circle, kind of a combination of shapes. I think if you can just think, all right, I have to calculate the area, try to break those strange shapes into shapes that you do know how to calculate the area of. And I think now specifically, as we showed here in a square, if you just figured out that there are smaller shapes that could be inside of it, there's a 45, 45, 90 triangle, or if you can recognize that there's a 30, 60, 90 triangle within a different shape, that's something that you're going to have to get good at. Again, it's good to know the formulas, but the tests are not simply spewing out the formulas cold like that. You have to be able to apply it within the context. So I think just practice, but just try and always break things down into the formulas that you do know, into the shapes that you do see, and then try to work outward from there, and just apply whatever rules you have to figure out the unknown variables. You have to.
Awesome. So moving on, we are dealing with the number of degrees in a polygon is another one. Here, the shape we're being given is a regular hexagon. So the number of degrees in a polygon, the formula for that is going to be 180 parentheses n minus 2. Another super important formula. These are all super important. But here for a hexagon, the n is the number of sides, so n would be 6. So 180 times 6 minus 2, right? So let's say we have a hexagon with a side length of 6. So the side length is 6. So each of these sides are 6. And we're being asked for the area once again. So the total number of degrees, 180 times 6 minus 2, 180 times 4 is 720. Regular is the idea that all the angles and all the sides are congruent, so it has a nice symmetrical shape. So we can take 720 divided by 6 and see that each of these interior angles are 120s. So this is like a common, almost staple type of math question on the ACT or the original SAT, a little bit here and there on the new SAT as well. But what you would next do would be drop some perpendiculars. So a little advanced. I mean, how many of you out there are daring enough to drop a perpendicular in a situation like this where you have an empty shape? So you got to really know what you're doing, have practiced a bunch. Okay, so if this is a right angle because I made it so, and each of those interior angles are 120s, then that means that we've got 90 here and 30 here. So this is another right angle. What are the angles of this triangle going to add up to? It's going to be a 30, 60, 90. So this has to be 60 to make it add up to 180. So now we're going to actually employ the idea of the 30, 60, 90 triangle. Across from the 30 is the x, across from the 60 is the x root 3, and across from the 90-degree angle is the 2x. And the side length is 6, so 2x is the 6. Any of those sort of hypotenuses of that type of triangle would be the side length right here of 6. So we just found out through that by dividing both sides by 2. X is 3. So we've got 3 here. And x root 3 is 3 root 3. Okay, so let's quickly get this complicated area. We've got 4 of these right triangles. And we've got one big rectangle in the middle, which I'm going to go ahead and highlight here in this pale blue. But I'm talking about this big rectangle in the middle here. And so we've got 4 of the turquoise triangles and one big rectangle. The turquoise triangle has an area of 1/2 times base 3 times height, 3 root 3, using all the special triangle stuff. And the one big rectangle, well, this side right here is one of the sides of the hexagon, so it's 6. And the height of the rectangle is 2 of the 3 root 3, so 6 root 3. So you can see how with a nice sort of basic formula-based question, we're in some hot water with just sort of a lot of stuff going on here. So just simplifying a little, we've got 4 divided by 2 is 2, times 3 is 6, times 3 is 18. So 18 root 3 plus 6 root 3. And the area of this hexagon would be 24 root 3. You know how to do that problem. If you have Ivy League aspirations or top college aspirations, or you want to save your parents a bundle of money, you need to be at the level of knowing how to do questions like this. And if you're not, reach out to us for tutoring. We could start tutoring you one-on-one anywhere in the world, online tutoring with a qualified tutor as early as today, even during the holiday season. Or comment and let us know what you want to see more of. If you need to go the free lesson route, we're more than happy to do that as this marketing tool.
And also to reach out to us, gradefultestprep.com is our site. Contact info is there, phone number, email for the moment. And there's a submission form also. You can submit any test prep question you have. You just have to tell us your email address, what test it is, and what the number is, and upload a picture of it, and we will solve it for you in real time on our live streams. So gradefultestprep.com is the site. And then also, so just back to what we're talking about here, this particular 30, 60, 90 situation, are there any other regular polygons that it would apply to, or you're just saying in general, break it down, drop the perpendiculars, and look for any of the
the hexagon is special. You'll see
Okay.
this applying to the hexagon more often than anything else because it's such a special shape, because when it breaks down, you get the 30, 60, 90 triangles. So I have never seen this sort of breakdown between the 30, 60, 90 triangle and the regular polygon with like octagons or nonagons or what have you. That would be maybe above the purview of the ACT. But you do need to know 180 n minus 2 applies to any shape. So a question could be what's the angle measure of one of the angles of a regular 12agon? And you can use this formula, 180, 12 minus 2, and divide by 12. So lots of different applications, which is okay. We've got all the time in the world to pump out all sorts of free content to help students all around the world who are finding Gradeful on YouTube.
Very good. So I'll let you take one more, and then we can wrap it up after that. So one more ACT formula you must know.
Oh, wow. You caught me off guard there because I just imagined we were going to wrap up. But I am apparently the math wizard, as I've been
I know
coined.
you can't be stumped. So
So, I might call
that's
myself.
for calling me calculator guy. That's for calling me calculator guy.
I might call myself the SAT math whiz more than wizard because of the religious implications, but what are you going to do? So let's say that we had something like 4x cubed minus 2x squared plus x minus 5, and we were dividing that by x plus 2, let's say. So what I'm saying is, as the guy that can't be stumped, very proud of that fact, I guess, is that in order to head into an ACT, you need to know how to do synthetic division. So let's practice that really quickly. Synthetic division is the idea that, there's a shortcut for long division. You can divide a polynomial, the long division style, the way you would do with regular numbers, and it is incredibly sort of prone to little minus sign difficulty. So this is the nice shorter way. There's no argument against synthetic division being the quicker way. But number one, with synthetic division, you divide by the root of a polynomial. So the root that goes along with x plus 2 is x equals negative 2. What do we mean? What do we mean by that? If we have a polynomial with a factor of x plus 2, that means that it hits the x-axis at x equals negative 2. Expect more lessons on that in the near future. That's one of the main primary threads through the redesigned SAT. But we have negative 2 going in our synthetic division box. Do you have something to add, Patrick?
Nope. Impressed as usual. Tweets.
That's my boy right there, my number one supporter, and it goes both ways. So we have x equals negative 2, 4 minus 2, 1, and negative 5 are the coefficients of this polynomial that we're dividing. So we're going to go ahead and bring down the 4. And the sort of saying you want to have in your head for synthetic division is multiply, add, multiply, add. So, it takes a little practice. I like to go to Kuta, Kuta software.com and put in the name of any of these. So if you go to Kuta software on Google, just type in Kuta and synthetic division, you'll get a whole worksheet full of problems on this with the answers, and you can work them out. But anyway, this is what you would be doing there. So bring down the 4, multiply, add, multiply, add. So multiply 4 by -2, -8. Add -11. Multiply by -2 again, 22. Add straight down again, 23. Multiply again, -46. Add straight down again, -51. So definitely certain people out there who might be watching this who've never done synthetic division before are probably going to be like, hold up, what was that? You're going too fast. And let us know. We'll be more than happy to do a lesson just on synthetic division. But when you get these answers here, the last thing you get is your remainder. So that's your remainder. The next thing you get is your constant, the number at the end, and then it keeps going in order. Next is your x squared. If you had more numbers, the next would be x third, x fourth, and so on. But just remember the first one's the remainder. So if this were quote unquote divisible, if 4x cubed minus 2x squared plus x minus 5 were truly divisible by x plus 2, then the last number would come out to 0, and that's how you'd know. But there's 2 ways to write this answer, and this is what I suppose we'll wrap up with. 4x squared minus 11x plus 23 with a remainder of -51. Or, if you're someone familiar with long division, you know that the remainder can be presented as a fraction over the thing that you're dividing by. So -51 over x plus 2. So what are we saying? We're saying that this polynomial that we just got, when you multiply that by x plus 2, you would get this. You'd get the answer. So multiplication and division are obviously sort of backwards versions of one another. So what do you think, Patrick? Still impressed with my SAT wizardry, ACT wizardry skills here? Okay.
Yeah, sorry, I had just little mic.
No worries. Technical things happen on live TV, right?
Very good. I think so. Just for anyone out there watching, if they want to go more in depth on this, we have a throwback SAT math lesson that covers synthetic division and polynomial long division. So look in our video library under the SAT math lesson playlist, because this appears on the SAT also, or it's one of the throwback math videos. Check it out. It's a whole video from a few years back, but synthetic division and polynomial long division are much older than that, and they don't change. So the math's the same. So just to wrap up again, we'll be back here again tomorrow. Free content. And if you guys have any questions, again, comment, subscribe, like the video. You can upload your questions at gradefultestprep.com. There's a submission form. Take a picture of whatever test prep question is giving you headaches, upload it. We'll answer it in real time for you. We provide one-on-one tutoring, group tutoring. So feel free to contact us. Everything's on our website. And stay tuned. We'll have a few more live streams for the rest of the week. And we'll see you guys here tomorrow at noon Eastern time. Thanks, Alex.
All right. Thank you. Talk to you guys soon.